Hi everyone, hi I'm Jeremiah. So let's solve the concluding question on the making of the mathematician. So we want to solve x raised to power s plus y raised to power y equal 31. That is the first equation, equation 1. And the second equation, s plus y equal 5. I told you to follow the approach I did in the first video for the series 1a. So from 2, that is the first thing we are going to do. From 2, that is from equation 2, you will make s the subject of formula. S will be equal to 5 minus y. Call that 3. After that, you substitute into equation 1. You substitute 3 into 1. So substitute sub 3 into 1. So what do we have? Yes, equation 1. Equation 1 is s raised to power. Equation 1 is s raised to power s plus y raised to power y is equal to 31. That is equation 1. So I will put s to be 5 minus y. 5 minus y raised to the power of 5 minus y plus y raised to power y is equal to 31. So at this junction, I'll take this y raised to power, I'll take this one to the other side, I'll bring this to the other side. So I will have 5 minus y raised to the power of 5 minus y to be equal to 31 minus y raised to the power of y. The next thing I'm going to do now is to take the ln of both sides, log to base e. Ln means logarithm to base e. Take the ln of both sides, 5 minus y raised to the power of 5 minus y is equal to ln of 31 minus y raised to power y. After that, according to the law of logarithm, this 5 minus y at the power can come to the back. This one at the power, we can bring it here. It becomes 5 minus y ln of 5 minus y is equal to ln of 31 minus y raised to the power of y. So next is to divide both sides by ln of 5 minus y. So I will divide both sides by ln of 5 minus y, so that I will have 5 minus y here, 5 minus y to be equal to ln of 31 minus y raised to the power of y all over ln of 5 minus y. I'll then make y the subject of formula. That is, you will take y, bring y to the other side, bring this y to the other side, and bring all this to the left hand side, so that y, you are going to have y to be equal to 5 minus ln of 31 minus y raised to power y, close the bracket, all over ln of 5 minus y. So at this junction, this is where we are going to apply the fixed point iteration scheme. So here, using the fixed point iteration, using the fixed point iteration. So here I'm going to use the fixed point iteration to solve, as I've done in the first video. So this one will become yn plus 1 to be equal to 5 minus ln of 31 minus yn raised to the power of yn all over ln of 5 minus yn. But now in this case, I will not let my y0 to start with 0. I won't let my y0 to start with 0 because 0 raised to power 0 is not really defined. It's not defined. So I will let y0 to start from 1. Let y0 be equal to 1. So it means that, of course, you will let n to be 0. This one will become y1. So I will have y1 will be equal to 5 minus ln of 31 minus y raised to power y0 raised to power y0 all over ln of 5 minus y0, and this will be equal to 5 minus ln of 30, ln of 5 minus ln of 30 all over ln of 4. How did I get 30? y0 is 1, so I have 1 raised to power 1. 1 raised to power of 1 is 1, so 31 minus 1 is 30. 5 minus 1 is 4, so you will use your calculator here. 5 minus ln 30 over ln 4. This will give me 0.55 corrected to 2 decimal place. So this has been corrected to 2 decimal place. Similarly, I will do for y2. Don't forget, the essence of this 6-point iteration is that we will continue to iterate. We will continue to go like this until we obtain the same result. That is, if you are getting the same answer, we stop, then we say it's converged, then the value of y will be the value we got after it converged. For y2 now, we are going to input our answer. We got this answer into it. You know, y2, that means n is 1. If you make n to be 1 here, if you put n to be 1, 1 plus 1 is 2, that's y2. So that means over here as well, it means that over here, this one will be y1, this also will be y1. So y2 will be equal to 5 minus ln of 31 minus y1 is 2.55. So I have 2.55 raised to the power of 2.55, close the bracket, all over ln of 5 minus y1, which is 2.55. You will also have to calculate this. Then when you calculate this, you will get, using your calculator, you will get 1.65 as the answer. You will go on to y3 as well. y3 will be equal to 5 minus ln of 31 minus y2 is 1.65, that's 1.65 raised to the power of 1.65, then all over ln of 5 minus 1.65, and this will be equal to, so the answer we are going to obtain here will be 2.22. You will go on this way to get y4. y4 will be equal to 5 minus ln of 31 minus 2.22 raised to the power of 2.22 all over ln of 5 minus 2.22. The answer you are going to obtain will be 1.84. You will do the same like that. Since, look at it, I got 2.55 here, 1.65, 2.22, 1.84. Don't forget I told you that this has been calculated to 2 decimal place. So it has not converged yet because I'm still having different answers. So I will continue. y5, you put y4 here. This will be 5 minus ln of 31 minus 1.84 raised to the power of 1.84 all over ln of 5 minus 1.84, and the answer you are going to obtain for y5 will be 2.y1. You will continue that process. You will continue this process. You will get y6. y6 will be equal to 1.92. So you can put y7. y7 will also be 2.05. You will go to y8. y8 will be 1.2. 97. You will go to y9. You will continue this process until it converge 2.02. This is quite long, but you have to continue if you want your solution to be accurate. Y10 gives 1.99. Y11 gives 2.01. Y12 gives 1.99. Y13 gives 2.01. So you can see something reoccurring, 1.09 and 2.01. 1.09 and 2.01, they are occurring. That means if I should compute y14, I will get 1.99, because when I put 2.01 into the function, I got 1.99. When I put 1.99, I got 2.01. So if I put 2.01 again, I'll get 1.99, and it will go on like that. So to get the value of y, because of this, y will now be equal to, since it is converging, it's as if it's let me use this word, is converging to two values, 1.99 and 2.01. So the answer will then be 1.99 plus 2.01 divided by 2, so that y will now be equal to 2, because this is 4 divided by 2 will give me 2. So I've obtained y. So to get s from 3, it's very easy to get s from 3. We have s to be equal to 5 minus y. So s will be equal to 5 minus 2. 5 minus 2 will be 3. Therefore, thus s is equal to 3 and y equal 2. So again, come to the question. If you replace y with s and s with y here, if you replace y with s and s with y, the question will not change. If I replace s with y and y with x, this one will become y raised to power y, because I'm replacing s with y, and this one will become s raised to power s is equal to 31. This one will become y plus s is equal to 5, which is exactly the question. Nothing changed. So similarly, replacing s with y and y with s. I don't need to go through the rigor of what I have proved above. I will just replace, since I have replaced it at the question, that means the final answer can also be replaced. That is, I will, instead of s to be equal to 3, I will replace s with y. Y will be equal to 3 now, and here s will be equal to 2. So that means the complete answer to the question will be s equal 3, y equal 2, or s equal 2 and y equal 3. So, and that is all for that. Watch out for the next making of the mathematician question or series. Now there is something there is something you should observe in this in the fixed point iteration. Now let me give you the number line. Let me draw the number line for you, and let's say here is 0, let's say here is 1, let's say here is 2, and say this place is 3. So in reality, the solution to that question has ended here. I just want to show you something I observe while solving this question. Let this be -1, not drawn to scale, -2, and let this be -3, for instance. So when I computed My y1 was 2.55. You can see that. Let me show you where 2.55 is. 2.55 will be somewhere here, right? And my y2, if you check again, my y2 is 1.65. My y2 is 1.65. You can see that. So y2 is 1.65. 1.65 is somewhere here. 1.65 is somewhere here. Y3 is 2.22. You can check. It's 2.22. You can see. Y4 is 1.84. 1.84 is, let's say, here. Y5 is 2.11. 2.11 is somewhere here. And then Y6 is 1.92. 1.92 is here. So 1.92 is here. And Y7 is 2.05. 2.05 is here. Y8 is 1.97. 1.97 is here. Y9 is 2.02. You can see. My point is, you can see that the using the fixed point iteration scheme, is from the right is converging, is coming down to 2. You can see it's coming this way, and you can see actually it's coming this way. Don't let me conclude that it's coming to 2. It's coming this way, and from the left it's coming towards this place. So they are meeting at 2. Actually, that means 2 the solution. They meet at 2. Both from the left and right limit. The limit to from the right is tending towards 2, and these are the odd values, like odd sequence of the solution. I mean y1, y3, y5, y7, y9. If you look at y1 is 2.55, y3 is 2.22. You can see it's coming closer to 2. y5 is 2.11, y7 is 2.05, y9 is 2.02, y11 is 2.01. So it now actually stop at 2.01. So it stop at 2.01 somewhere here. Now from the left, that is according to the even sequence, y2 is 1.65. y2 is 1.65. You can see y4 is 1.84, y6 is 1.92, y8 is 1.97, and it's coming closer to 2. y10 is 1.99, y12 is 1.99. So 2, it's actually, as if you continue like that, as n goes to infinity, you will see that this will convert to 2 if you continue as it goes to infinity according to analysis. So the solution is correct. Thank you very much.